G'day everyone, in this we are looking at application questions relating to exponential growth. So in here we've got a question, a biological culture contains 500,000 bacteria at 12 p.m. on a Sunday. So you can already see that's our important information. The culture increases by 10% every hour. At what time will the culture exceed 4 million bacteria, not 40 million. So just with exponential growth and decay, you can use one of these two formulas here. I prefer this one. It sort of depends on how the question's stated. You'll see it expressed with different letters depending on the textbook or the website, wherever you're reading it from, but it's the same principle here. So what we need to identify first, our y is our total amount. So in this question here, our total amount is what we want to see at the end, and this is this 4 million bacteria. So if we have y, and I'll just put it in the same format as here, a, b, t. So y is going to be equal to 4 million. Don't know why my pen's not working for that top bit there. Make sure you get the right amount of zeros. 4, 5, 6. Okay, so we've got 4 million is our y. Our a value, this is the initial amount, so the biological culture contains 500,000 bacteria. That's going to be our initial. I don't think it's going to fit in this little spot here. Might need to write it a little bit smaller. So we've got 4 million is equal to 500,000, which was our initial amount. Okay. And then we've got our b value here. So this is our exponential growth or decay. So it increases by 10% every hour. So this means it is exponential growth because it's growing, it's increasing. So this here makes our b value, and you can see, or this here you could say is equal to 1.1. So if you're using this formula here, it's 1 and our rate was 10%, which is 0.1. So that's what makes it 1.1. So this is 1.1. And our time, that's what we're trying to work out. Okay, what time will the culture exceed 4 million bacteria? So this is how you do set it up. Just set it up, write out your equation, work where everything goes within it and what you need to figure out. So we've got all of this information here now. So what we can actually do is we can simplify this down a little bit. So first, I'm going to divide both sides by 500,000 because that goes into 8 million. Nice. 4 goes into 4 million. I was thinking about the answer of 8 nicely. So 500,000 divided by 500,000. So this just leaves our 1.1 t on this side. Now we've got a fairly simple exponential here, so we can actually convert this to a logarithm to find our unknown. So just remember this, when you convert it to a logarithm, then turns it to log 1.1. 8 is equal to x. So now we can just put in log 1.18 into our calculator and you've got your answer, which will equal to, oh sorry, I changed from a t to an x. Should be t. So time is equal to, so this will give us 21.82 hours. If I did it correctly before. So 21.82 hours when you do this on your calculator. So we haven't answered it because it says at what time will the culture exceed 4 million bacteria? Okay, so this is the total time it's taken. So this is 21.82 hours, but it started at 12 p.m. on a Sunday. Okay, so we need to do 12 p.m. Sunday plus 21.82 hours. Okay, so you could, if you wanted to, you could round this up to 22 hours. Okay, so because it's looking at when it would exceed 4 million bacteria. So here 22 hours after 12 p.m. on a Sunday. I just sort of gave it away. This is 10 a.m. Remember, 12 p.m. is midday. So this is 10 a.m. Monday. It will exceed 4 million bacteria. So if we're just looking at hours there. So going over these application questions, you really need to focus on what information you've been given in your question. So make sure you do what I did, highlight all this important information. Then have your equation. So you can use this one or this one. This one was sort of more like a rate. So you do the 1 plus 0.1. Okay. So if it's decay though, it'll be minus. So if the value is going to be decreasing, it would be 1 minus 0.1 for this example if it was decreasing at 10% every hour. So make sure that you're just aware of that and then fill it out into your equation, and then you'll need to solve for your unknown. So if it's up the top here, the time that you're looking for, you will need to convert it to a log. If it's not the time you want, you're looking for, you'll have to just use algebraic techniques to solve it. Okay, and then you should get your answer. And then finally, make sure that your answer reflects what the question asks. Okay, so that's a big thing. People do all the right maths, but then they don't actually get to answering the question. So make sure you do that at the end. So hopefully this helps, and good luck.